Ismail or Guvenc. Ismail, are you there?
I'm here. Can you hear me?
Okay, great. You can share your screen while I introduce you. Ismail Guvenc is a professor at the Department of Electrical and Computer Engineering in North Carolina State University. His recent research interests include 5G, 6G wireless networks, UAV communications, millimeter wave terrestrial communications, and heterogeneous networks. He has published more than 260 conference journal papers, several standardization contributions, 4 books, and over 30 US patents. He's a recipient of the 2019 R. Ray Bennett Faculty Fellow Award, 2016 FIU COE Faculty Research Award, and many other awards. And he is a senior member of the National Academy of Inventors. Yes, please.
Thank you very much. Thanks for the opportunity to present our work. Yes, I have to see. Just a second. Yeah, so today I will talk about our project AERPAW, the 3 power projects. We were awarded just over a year now, and we are still working on finishing our phase 1, and we are expecting to open the platform by maybe February or March for initial experimentation by external users. So the power projects, as many of you may be familiar, these are large-scale platforms for advanced wireless research. The 2 others that are ahead of us are Powder in Utah and Cosmos in New York City. For our platform, we focused on aerial experimentation. We have basically autonomous vehicles, both actually aerial vehicles as well as ground vehicles. And we are aiming to deploy more than 30 fixed nodes by the end of 3 years. And the first phase is finishing early next year, as I said earlier. During the first phase, we are deploying 3 fixed nodes, and I will talk about what are those fixed nodes, what they have, what are the portable nodes. But initially, we are deploying 3 fixed nodes. 2 of them are in our Centennial Campus. This is our engineering campus, and you can see downtown Raleigh a bit to the east of our campus, and we have the main NC State campus right here. And we have a 3rd one, which is a full 60-foot tower in the Lake Wheeler Field Labs, which is also part of NC State. So right to the south of our engineering campus, we have another area that we have our College of Agriculture and Life Sciences do research, and we are deploying basically most of the drone experimentation will be there. And we are also starting deploying in Town Oak area in our phase 2. You can see the yellow locations. These are going to be deployed by early 2022, and the blue by early 2023. So all the yellow in the Centennial Campus, actually, they belong to a testbed called SandMesh, which has been deployed about a decade ago on 802.11s networks. We have been getting a lot of equipment and in-kind contributions from many different companies, and this shows most of those, especially USRPs and equipment from Keysight. This is the team. I will maybe skip this, but mainly NC State is leading the whole project. We are partnering with MSU on SDR development, Wireless Research Center in Wake Forest for deployment and operations, Ramsey for emulation of Emulab from the Powder platform, but we are doing a lot of additional development as well. Quick progress updates. I wanted to show the latest on where we are. We have a lot of information in our website, aerpaw.org. This shows the current status of our tower in the Lake Wheeler area. This is a tilted tower, so you can bring it down and put equipment. We are going to deploy commercial base stations, SDRs. This will be the heaviest loaded basically node in year 1, and you can see the aerial, basically the images of this area, the hut and the tower. They were not there a couple of months ago. This area didn't have any fiber, so we pulled fiber from a long distance. All our towers will be fiber connected, obviously. So we are already flying drones here for our individual experiments, but now it will be part of AERPAW in a controlled environment. And as far as the Centennial Campus nodes, we will have rooftops and light poles. We were planning to use the existing light poles that belong to Sandmesh testbed, but it ended up that they don't carry the payload, so we are now deploying the purpose-built light poles that we received. So this is the first light pole. It's already deployed actually right now. And the rooftop nodes, they will look like this, and you can see the enclosure from CommScope. It will house the servers and USRPs and the other equipment. The same thing is actually next to this light pole. So what do we have in these fixed nodes? All of those fixed nodes will have USRPs. So we are going to have 3 USRPs, and we are very close to deploying these. So we have fiber connected all the 3 fixed nodes now. We have antennas mounted. We are placing the switches, and we have the front ends and the USRPs. They are close to ready to deploy. So in the coming weeks, they will be deployed. So all the fixed nodes, they will have USRPs. They will actually have 3 USRPs. One of them will be actually for spectrum compliance monitoring. We don't want to interfere with any neighboring incumbents. So we have certain permits to transmit in certain frequencies. We will monitor that. We will deploy to some of those fixed nodes RF monitoring sensors from Keysight. These are really great equipment for drone tracking, RF sensing, spectrum sharing, many different applications. Telegraph radios from Facebook. We are deploying actually 4 different locations this year in phase 1. Drone detection radars, LoRa equipment, and we have a commercial base station, 4G/5G, arriving end of January to be deployed in Lake Wheeler area. We have Dell, as far as the compute, basically platform. In each of the enclosures, we have Dell Intel Xeon servers. And we just recently received this emulator platform from Keysight called PropSim. This is really capable and expensive in-kind contribution from Keysight. It is a smaller version of Coliseum, if you are aware with Coliseum. It has 32 ports, so you can plug in up to 16 different equipment like USRPs, sensors, LoRa, and it emulates different channel models, whether if it's statistical based or geometry based. So we have an emulation stage before we go to over-the-air experiments. The portable nodes we have are smaller versions of USRPs, mobile phones, sensors, and we have an Intel NUC basically that will be carried by vehicles controlling the small USRPs. And we have several different types of vehicles. You can see our drone here. We have a custom-built drone. We want to have full control of what the drone does. So we have the Pixhawk and Ardu Pilot, and you will have full control on the trajectory of the drone. And the same drone control, same trajectory control will be possible also with the UGVs, again with the Pixhawk. We will also have a helikite that can go to a bit higher altitudes, and you can leave it for longer durations. This is from a company called Carolina Unmanned Vehicles, and we will also deploy your portable nodes in shuttles. This pretty much repeats what I said in the earlier slide, but with some timeline. So one important thing that I want to emphasize is our SDRs will be the only equipment that will be generally available by early next year. So you will be able to access them through our experimental portal. You will be able to run VMs in SDRs. All the other equipment, we are deploying them this year, and we are testing them. And we hope to integrate them into our experimentation portal during our phase 2. But if you are interested in any experiments with RF sensors or like IoT devices, telegraph, we can do it in a case-by-case basis, but not through the portal. And this slide shows how we are planning to scale across 3 years with USRPs. So we will have 15 more towers, and in year 2 and 14 more. Sorry, the dates are a bit outdated. But so this by the end of year 3, it will be early 2023. And we are looking to getting 32 fixed nodes, 23 portable nodes with USRPs and Intel NUC in each of them, and we will carry these portable nodes in vehicles. You can take the same portable node, put it in a drone or an unmanned ground vehicle. You can control both the wireless and the trajectory of the vehicle for as far as UGVs and UAVs are concerned. A little bit about the software that we are planning to support. So we are going to support a lot of the open source software that, for example, Powder also has. We have been testing how they do. So SRSLT, open air interface, 5G with open air interface, which we are working on some stability issues, profiles with GNU Radio and MATLAB. So we have developed several example experiments. And we have a wiki page on the top. The easy way to access it is to go to aerpaw.org and then go to bottom right, and there's a link to our wiki page, and you can access these pages. So we tested all these with VMs, and they are working well. So we were planning to do pure VMs, but now we are working with Dockers and containers, which seem to be more stable. Just briefly about some other equipment. I mentioned about Telegraph. We are deploying it actually in 4 additional locations right now, in addition to the 3 fixed nodes that I mentioned. So before we put our USRPs, actually the Telegraph equipment are being deployed right now. They are operated at 60 gigahertz, and you can do beam scanning, beam steering. Initial applications are channel sounding and environment sensing, RF sensors from Keysight, and we have plenty of information in each of these links. So I will skip a bit past, but we are very interested in using these for spectrum sharing, like NRDZ, dynamic zone type of context. And we have some profiles with LoRa. So we have 2 tracks for LoRa. One of them is more for experimentation at physical and MAC layers with USB dongles. So you can change parameters and check the performance over the air. We also have more application-based LoRa to deploy them, deploy a gateway and a lot of commercial sensors and collect data over longer periods of time. And this slide shows our vehicles. As I said, we have built the vehicles from scratch. This shows our drone. We tested its flight a couple of weeks ago. Everything is great. We are doing one more of that, and you can see our UGV here, again using the same interface that we can control the trajectory. So you will be able to do experiments, for example, by autonomously controlling the trajectory of the drone to stay within the coverage of, let's say, a given base station. And we are already flying every Friday, the weather permitting, the drones. We have done several individual, we have supported several individual projects, not through our portal, which is still being finalized. As far as the experiment workflow is concerned, I have a bit more than 2 minutes. We have multiple stages, so you can work on developing your own software. We will support a sandbox and an emulation platform. So I talked about PropSim earlier from Keysight. So we will try to replicate actually the experimentation environments in AERPAW in the emulation environment by generating the point clouds, and we started doing that with scanning them with LiDARs. And then we will try to generate the same channel impulse responses when, for example, the drones are moving in the PropSim. So they will observe a similar propagation environment as we have in the AERPAW, for example, in the Lake Wheeler location. And then once you do some initial testing with the emulation environment, which will support real USRPs, real drones without the propellers, but you will be able to emulate the drone flight as well. Then you can submit them into for over-the-air experimentation. We have several pilots. They will go click a button, and then your experiment will run, and then you will be able to download the collected data after the experiment. So this is a high-level overview of our plan for the experiments. And this is my last slide. I think I'm almost out of time. It just shows a couple of experiments, different experimentation possibilities. And what you see with a POW here, it refers to an AERPAW wireless node. It may be a USRP, it may be a mobile phone, it may be a LoRa gateway or a LoRa sensor. So we are thinking of experiments. For example, you may have a UAV carrying a sensor or a USRP, and you may be measuring existing wireless base stations coverage, for example, from some of the operators. And they don't obviously have AERPAW equipment. You may have smart agriculture experiments, especially the Lake Wheeler area. We are very excited to work with our College of Agriculture and Life Sciences people. They use these type of sensors for in the agriculture context. We may have a LoRa gateway and collecting data for long periods of time. You may also fly a drone that carries a LoRa access point, for example, to collect data. We also support experimentation where you may have a base station with AERPAW equipment. It may be a USRP, it may be a drone detection radar. So it may send radar signals and capture back for counter UAS type of experiments. Or you may also passively monitor the signals from the drone and classify the drone signal, the communication going on with the drone and the ground controller, for example. We have several work in that context, and we are planning to extend in AERPAW. Obvious 4G, 5G, next G type of experiments, and I will go fast. So V2X networks, cybersecurity, multi-hop communications, millimeter wave beamforming. So very briefly about millimeter wave. This is the development for millimeter wave is in our plans for year 2. We have been working with InterDigital to receive some equipment from them, pretty much the same equipment that Cosmos is deploying, so that they will be integrated with UAVs by the end of our phase 2. And finally, the trajectory optimization. So like I said, you may have very interesting trajectory optimization, including multiple drones under, for example, connectivity constraints. And that finishes my talk. So,
okay, thank you very much, Ismail. If there are any questions,